Good day, everyone, and once again we are back together. Welcome to our YouTube channel, and we are looking at trigonometry, still continuing on our lessons. All right, so today I am going to be looking at trig identities, and if you are new to the channel, please just consider subscribing and of course hit that notification bell just to make sure that you are notified every time that we are posting a new lesson. Of course, I'll still continue to be your plug when it comes to maths and science. And for those of you who might need assistance in mathematics or physical science, of course, you're more than welcome to send us an email. And our email address is info@mlungisinkosi.co.za. All right, so today I want to start a lesson on trig identities. I am not going to cover double angles just yet, but we're going to get there. All right, so the first thing that I want us to remember, I'm just going to give you some rules in just a bit. Okay, so every time that we deal with trig identities, first of all, we just need to remember square identities. And of course, the most prominent one is when we've got the sine squared of theta plus cos squared of theta. We know that is equal to 1. But something else to consider, of course, you can always, just take the cos squared of theta, just rearrange it and make cos squared of theta the subject of the formula. Okay, and in this case, that would be equal to 1 minus sine squared of theta. Of course, as well, you can express it as sine squared of theta is 1 minus cos squared of theta. Okay, by the way, for these two, just note that you can also express them as the difference of two squares. What I mean by that is that we can factorize both of these. For instance, 1 minus cos squared of theta, you can factorize to be 1 minus the cos of theta and 1 plus the cos of theta. Okay, so we can always express it that way. And for that one there, 1 minus sine squared of theta, you can always express it as 1 minus sine of theta and 1 plus sine of theta. Right, this can come in quite useful, okay, at any given point. By the way, what we also know is that the tangent or the tan of theta, okay, and it could be any angle, tan of x, tan of whatever it is. Okay, so tan of theta, we can always convert to being the sine of theta divided by the cos of theta. Now, before we go any further, what I would like to do is just give you a couple of rules, nothing really too difficult, okay, when it comes to trig identities. Okay, just first of all, what are you going to do when dealing with identities? So first, I want you to please remember the following. Always try, okay, you must always try to convert everything. Always convert to sine and cos, sine of theta and cos of theta. Okay, so that's the first thing that we do. And secondly, always try to, if you've got fractions, okay, try to resolve any fractions, okay. So try to resolve fractions or get rid of fractions if possible, okay. Thirdly, especially when it comes to proving identities, where you're supposed to prove whether left-hand side is equal to right-hand side. Work with both sides separately, okay? Work out both sides separately. Okay? And then just another thing to consider there, okay? If possible, there might be instances where you might find that you might need to factorize, okay? Just look out for opportunities to factorize. Okay, so just like I showed you previously, that you can actually express 1 minus cos squared of theta into 1 minus cos 1 plus cos, okay, the difference of two squares. And then just another thing to consider, all right, please just remember in this case, once you've worked out both sides, of course, that's when we can say left-hand side is equal to right-hand side. But just another thing to keep in mind, okay, if at all necessary, you can actually replace, any number. For instance, you can get 1. You can convert 1 into, remember the identity cos squared of theta plus sine squared of theta, and any number for that matter, okay? For instance, if you had a 2, okay, just remember this could easily be 2 cos squared of theta plus 2 sine squared of theta, okay? Just keep that in mind. All right. Obviously, I want us to get right into it, okay? Let me see if I'm not leaving anything else. Okay, yeah, I think that's just about it. Okay, so now what I want us to do is I want us to look at a couple of examples. Of course, I don't want us to get bogged down, with the theory. I want us to get into that practical, okay, the practical side, and let's try to, as much as possible, just do the practical part of things, okay? All right, now let's look at the first example that we have. Okay, so they say prove the following identities. All right, so we've got cos of theta plus, or rather into 1 plus tan squared of theta, which is equal to 1 over cos squared of theta. Now remember, we're trying to prove left-hand side equal to right-hand side. So what we're going to do now is just separate the two sides. Okay, so let's work with the left-hand side. So in this case, remember we said the first thing, you're going to always change everything into sine and cos. Okay, so we're proving the identity. So the left-hand side is going to be cos of theta. Okay, 1 plus, now I'm looking at tan squared of theta. Can I express it differently? Of course, I'm going to change it into sine squared of theta. Okay, so that's going to be sine squared of theta divided by cos squared of theta, right? I'm going to leave the right-hand side as is, so that's going to be 1 over cos of theta. Just leave it as is, right? So now, okay, so now we're going to try and get rid of any fractions and so on. Okay, so now we're going to have the cos of theta. Okay, now let's try to multiply into that bracket there. Okay, so I've got that multiplied by 1, which gives me cos of theta. And I'm going to say cos of theta multiplied by that entire fraction. Okay, so this would be plus, okay, let me just show it fully. So that would be cos of theta multiplied by sine squared of theta over cos squared of theta. Okay, of course you could have chosen to work with it differently, okay, but I'm just going to keep it like this. Okay, so now what I'm going to do is I will now have cos of theta, so this cancels 1 of the cos squared. Remember, cos squared is cos times cos theta times cos theta. So one of these will cancel one of the squares. So I would have cos of theta plus sine squared of theta divided by cos of theta. Now we still have a fraction, right? So let's try and work out that fraction there and see if there's a way in which we can simplify it. Okay, so now all I'm going to do is, of course, we need to find the lowest common denominator. So I'm going to make that cos of theta divide by 1. So what is our LCD? And I'm still going to, as I said, I'm going to treat fractions with you, okay, but at a later stage, so that you know how to work with that. Now, what is our LCD, our lowest common denominator in this case? And remember, our lowest common denominator should be such that both of the denominators can actually become factors into that LCD. Right, in this case, what is our LCD? It's going to be the cos of theta, right? So now, how do we work with fractions? We always say LCD, we take the LCD, we divide by the denominator. Our denominator is 1 in the first term, okay? In this case, so that's going to be cos of theta. So it's going to be LCD divided by the denominator. Let me just put that in color. So cos of theta divided by 1. So that will give me cos of theta. And I'm going to multiply that by the numerator. So remember, you always say LCD divided by denominator multiplied by the numerator. So cos of theta divided by 1 would be cos of theta, okay, multiplied by cos theta, so that would be cos squared, okay. So I'm making that into one fraction, so that would be cos squared of theta. Now remember, we had that plus sign there. I'm going to put this in red again. So now again for this term here, okay, so we're going to say this would be cos of theta LCD divided by the denominator. So cos theta divided by cos theta would be 1, okay, multiplied by sine squared of theta. You can see how that will give me sine squared of theta. Right, and obviously all of this will be divided by my LCD. So this will be divided by LCD, which is cos of theta. Right, now you can see that identity there. Cos squared of theta plus sine squared of theta, of course, that changes into 1, okay? And that is divided by cos of theta. And that is how our cookie crumbles. Look at this, our left-hand side is equal to right-hand side. So I can therefore conclude left-hand side is equal to right-hand side. And that is how we're going to solve that one. Right, we're going to take another example, okay? I want you to learn how to work with those fractions, okay? So that's why I'm going to take the next example. All right, so we look at our second example. So again, we're trying to prove left-hand side equal to right-hand side. So we're going to start there. I'm going to separate between the two sides, okay? So, all right, so let's start with the first one. Okay, so if I look at that again, I've got a fraction and there's nothing that I can change into sine and cos there. All right, so the first thing we need to do, just resolve those fractions there. Now, what would be our lowest common denominator? So in this case, it's going to be sine of x multiplied by 1 plus cos of x. So that is our denominator, right? So keep in mind, what did we say about the denominator? We always, or rather to make this fraction into 1, okay, so we're going to say LCD, so take the entire LCD divided by the denominator, so take the entire LCD divide by the denominator. You can see how that whole thing will divide, will cancel that whole thing in a sense that so we will now be left with sine of x, right? So remember, LCD divided by denominator multiplied by numerator. So that and that cancel. We're left with sine x multiplied by the numerator. So as a result, what will be left in that case? It will be sine squared of x. Okay, right. So, and then we take again for the next term. All right, so remember, everything should be divided by the LCD. So LCD is sine of x into 1 plus cos of x. Okay, remember, we're taking that whole thing and making it into one fraction. Okay, so in this case again, for the next one, so this is plus, because we had a plus sign there, Again, we're taking the LCD now. Let me just put it in another color. Okay, LCD divided by denominator. You'll see how now these will cancel. So I'm left with 1 minus cos of x times cos of x. So it's that cos of x there into that bracket over there. So now I will have cos x into 1 plus cos of x. Right. So now let's try and try and simplify that. So I'm going to take the top. Okay, there's nothing we can do there. Sine squared of x plus, so I'm going to multiply into that bracket there, cos of x times 1. That's cos of x. And then cos of x multiplied by cos of x plus, okay, let me just write it in white, plus cos squared of x. And this is all divided by sine of x 1 plus cos of x. Right. Okay, I hope that you are still able to follow. So you can see how we have that identity again, sine squared of x plus cos squared of x. Let me reduce that into 1. Okay, so that will be 1 plus cos of x. Remember, those two have formed 1. And in this case, we still have the cos of x. And this is all divided by sine x over 1 plus cos of x. Now, can you see how we've got something similar at the top and at the bottom? Right? So we can cancel that out. So in that case, this divided by that will give us 1. Okay? So as a result, what are we now left with? We've got 1 over the sine of x. And by the way, what did they ask us to prove? It's exactly that. So now we can say, therefore, left-hand side is equal to right-hand side. Okay, so I hope that has been understood. Okay, let's take the last one, and of course, we'll wrap it up. Alright, so our last example. So let's try to do that together. I'm sure you are getting the gist of this. Of course, we're going to have left-hand side and right-hand side. Okay, in fact, you know what? We're going to try and do this a little bit differently. Again, we can try to make that fraction into 1. Okay, by taking the lowest common denominator again, right? So in this case, what is our lowest common denominator? We'll take both of those. So that will be 1 plus sine of alpha, and that will be 1 minus sine of alpha. All right, now, remember, what do? We always say LCD divided by the denominator. So for the first term, okay, so you'll see how that will cancel with that. Okay, multiplied by the numerator. So what is left in this case? I'll just put that in green. Okay, what is left? Multiplied by 1. So in this case, let me just start by writing the denominator. So that will be 1 plus sine alpha 1 minus sine of alpha. Right, so in this case we said LCD divided by denominator, that and that cancel, and in this case multiplied by 1 minus sine alpha. I've got 1 minus sine of alpha at the top, plus, which is that plus sign over there. Okay, now we've got LCD divided by that denominator. So you'll see how 1 minus sine of alpha will cancel. So put that in yellow. So this will cancel that. Okay. So in that case, multiplied by the numerator, which is 1. So what you'll have is 1 plus sine of alpha. Okay, so take this, in this case, what will it give us? So you'll see, in this case, minus sine alpha and sine of alpha will cancel out, obviously because they've got opposite signs and that's the same thing. And now we're left with 1 plus 1 at the top, which is equal to 2, okay, over 1 plus sine of alpha, 1 minus sine of alpha. Now I'm trying to show you something that you can actually work on both sides to get to your answer. Okay, so we can actually take the right hand side. In fact, you can multiply here and get the difference of two squares, which will ultimately be equal to cos squared of theta. But I want to show you sometimes it may be necessary. You may work on the left hand or on the right hand side and say, but what is my right hand side? It's 2 over cos squared of theta. But what's cos squared of theta? It's 1 minus sine squared of, or alpha in this case, right? And you can either choose to factorize there and say, well, but I know if I factorize, it would be exactly the same as that, which is the difference of two squares. Or alternatively, you can say, well, but I know in this case, if I use the FOIL method, what will I end up with? So it will be 1 multiplied by 1, in this case, which will be 1. It will be 1 multiplied by minus sine alpha, which will be minus sine alpha. Sine alpha times 1, which will be sine of alpha. Okay, so maybe let me write that out instead of just saying it. Okay, so that was 1 multiplied by 1, which gave us that 1 there. Okay, and then 1 minus sine alpha, which would be minus sine of alpha. Just trying to show you how we get the difference of two squares there. And then we've got, I'm going to make it in green, sine of alpha times 1. That will give us the sine of alpha. And finally, you've got sine of alpha multiplied by negative sine alpha. And that should give us minus sine squared of alpha. Okay, so you'll see how this now, we will cancel minus sine alpha and sine of alpha, and you've got 2 over 1 minus sine squared of alpha. Now, please, I want you to know, because you are mathematicians, I'm expecting you to know, to be able to quickly identify the difference of two squares. Once you've got two brackets that are exactly the same, but the only difference is the sign between the terms, in this case we end up with the difference of two squares. Not only must you know this, but you must also know how to factorize. So if I give you something like this, you must be able to quickly identify this will be the difference of two squares. And how do you do that? You factorize the difference of two squares. You'll always take the square root of each, and of course you take different signs on each bracket. Okay, so finally you can see left hand side is definitely equal to right hand side. So in this case, left hand side equal to right hand side, and as a result it's been proven. Okay, right, so in our next lesson we're going to be looking at, including compound angles and double angle identities. Okay, and of course, I want you to perfect this method of, knowing how to prove identities. Okay, right, so please, if you haven't subscribed, please just consider being part of the family. Okay, just hit that subscribe button. Just do it now. Okay, right, and please don't forget to please recommend this channel to as many people as you possibly can. Tell them that, hey, this is a real plug. Okay, and I'll see you guys again next time. Sharp, sharp.